Dear students, this is Divak Shah from LG Institute of Engineering and Technology. We have been learning the subject basic electrical engineering, and we are in a continuation to learn about the AC circuits. Now, in our previous lecture, we have discussed about purely resistive circuit, purely inductive circuit, and purely capacitive circuit. Right now, in our today's session, we have to combine R, L, and C. So, in our first part of discussion, we are going to take a series combination of R and L, and then we apply the AC signal E is equal to Vm sin omega t. After that, we learn about the series combination of R and C, and subsequently learn about we combine R and C all together in a series. Right. So let's first start with the RL series circuit in our part of the AC circuit. Right. So we'll start our first theory, which is called part of the AC circuit. Right. So we'll start our first theory, which is called series resistance inductance circuit, which is called a RLC circuit. Now, our 3 points are the common point. Where point number 1 is we have to find the relation of voltage and current. Point number 2, we have to draw the waveform and phasor diagram. Point number 3, we have to go for a calculation of power, and that power P is equal to V into I. Right. So let's start with our first term, that is the relation of voltage and current. Since here we are going to combine resistance and inductor in series, so that is a little bit confusing, right? So let's first discuss there is a series combination of resistance and inductor. The voltage across resistance is VR and the voltage across inductor is VN, right? Where we apply the AC sinusoidal signal Vt is equal to Vm sin omega t. Right now, from here, my job is to find the individual phasor diagram of resistance and inductor. You know, the individual phasor diagram where for a purely resistor, voltage and currents are in a phase. But this is not case with the inductor where in the case of inductor, current which is lagging by angle 90 with respect to voltage. Now at this particular moment, I create confusion. So when there is a confusion in AC circuit, only one point or only one person can help you. This is called a phasor diagram, right? So from this I can be able to draw the phasor diagram since I am combining resistance and inductor in series. So here the job is to combine individual phasor diagram of resistance and inductor, right? So from this I can be able to write. Let's say first I am taking the vector current is same for both the cases because the current which is flowing through is the series combination is same since the circuit is in the series combination of R and L, right? So here the voltage drop across resistance VR which is always in a phase with the current, right? So that's what I have taken the vector on a phasor diagram. Same way, now the voltage across the inductor which is 90-degree ahead than the current. So I can represent this factor is Vn. So from this now, if I apply a parallelogram method, I can be able to find my resultant vector V. That is my applied voltage, and that is in a diagonal of this. From this, you can also able to find the resultant value of angle phi. So from this, I can define the relation of voltage and current like this way: V is equal to Vm sin omega t. I is equal to Im sin omega t minus phi, and that phi is for my resultant angle. You can see from this phasor diagram. So here, from the phasor diagram, I can be able to find the relation of voltage and current. Right. So here the phase difference is minus phi. Straight away here, current is lagging by angle phi with respect to the voltage. So from this, you can also define Im is equal to Vm divided by Z, and that Z is defined as the impedance that we'll discuss in a minute. We have discussed on point number 1, which is called difference between voltage and current. Point number 2, we draw the waveform and phasor diagram. So here we discuss the phasor diagram. Now next job is to draw the waveform. So from this, you can see here from the voltage starts at angle 0, but the current starts at angle minus phi. right? So current start at angle minus phi. That's what the phase difference between voltage and current for a series RL AC circuit, right? So point number two, where the draw the waveform and a phasor diagram. Straight away you can see here. Now point number three, where you have to find the power calculation. So power calculation P is equal to V into I. So you can see here, instantaneous power is nothing but the multiplication of instantaneous values of voltage and current. So from this you can find PT is equal to V into I, where V is equal to Vm sin omega t and I is equal to Im sin omega t minus 1. So once you multiply with this two term, you can be able to find Pt is equal to 2Vm into Im into sin omega t minus 5 divided by 2. So here you will see 2ss. So from 2ss you can be able to convert into trigonometry, which is called C minus C. So from this you can be able to find the power, instantaneous power P T is equal to Vm Im by 2 into cos phi minus cos 2 omega t minus phi. Right now, again, you will find here total two important terms. One term is defined as Vm Im by 2 into cos phi. Another term is Vm Im by 2 into cos 2 omega t minus phi. Since it is the cos 2 omega t, so the second term you define as a fluctuating term. So the average value of this fluctuating term you define as a 0. So from this you can be able to write power P average. You will find the P average value, that is by taking the integration with the interval from 0 to 2 pi. So P average value is equal to integration of from 0 to 2 pi Vmi by 2 into in bracket. You will see here cos phi minus cos 2 omega t minus phi. Right. From this you can be able to write Vmi by 2 pi from 0 to 2 pi 1 half cos phi minus cos 2 omega t minus phi. Right. Now taking the individual integration, you can be able to find the equation P average is equal to Vmi by 4 pi in bracket cos phi omega t from 0 to 2 pi limit minus sin 2 omega t minus pi divided by 2 from 0 to 2 pi. So from this you can be able to find P average is equal to Vm by 4 pi in bracket 2 pi cos phi minus Vm Im by 8 pi in bracket sin 4 pi minus sin minus pi. So from this you can be able to find the P average value, that is equal to Vm into cos phi minus 0. So here the second term, that was fluctuating term, since the having the term is cos 2 omega t. So that fluctuating term, the average value of power is equal to 0. So from this you can be able to find P average value is equal to Vm by 2 into cos phi. Right. So I can write this equation in P average is equal to Vm by root 2 into Im by root 2 into cos phi. Right. So finally Vm by root 2 and Im by root 2 is nothing but Vrms and Irms value. So from this I can be able to write the equation of P average for series RL circuit is Vi cos phi. Right. Now since this is a combination of these two components R and L, so the power calculation is must be very complex. So from here there is a power calculation from the resistance side, there is a power calculation from the inductor side, and the complete circuit power. So here power consumption done by the resistance, power consumption done by the inductor, and the overall circuit power that we need to calculate. From this we can be able to going more detailing into our phasor diagram. You can again observe the phasor diagram. From this you can straight away see the triangle as the your x-axis defined as the voltage drop across the resistance, and your y-axis is nothing but the voltage drop across the inductor. So once you take this triangle, from that you will find your diagonal, which is your applied voltage V. So from this I can be able to define my voltage triangle, where you can see here my first term is the voltage triangle, where the x-axis defined as a VR, and that is nothing but the voltage drop across resistance is I into R. Y-axis defined as the voltage drop across the inductor, VL is equal to I into XL, where XL is called the reactance of inductor, and my overall circuit applied voltage V, that is equal to I into Z. So my first job is to derive the equation of Z. So from this trigonometry, if I am going to use the Pythagoras law, where I can find my V is equal to under root VR square plus VL square, where VR is equal to I into R, VA is equal to I into XL. So from this I can be able to write V is equal to I in bracket uh, V is equal to I under root R square plus XL square. Since here I can replace the term under root R square plus XL square as the Z. So here Z is called a new parameter which is called impedance of this RL series circuit, right? So my final equation V is equal to I into Z. That's called my diagonal magnitude, right? So from this I can be able to write I is equal to V by Z, right? So after this, once the value of current, since both resistance and inductor are in series, so value of current is same throughout the series operation. So if I'm going to remove the current from all vectors, I can find the impedance triangle. So you can see here impedance triangle, the second portion, where once you discuss all these points, all this equation, you can see here the impedance triangle where Z is equal to under root R square plus XL square, right? So from this, you can find the resultant angle phi, that is equal to tan inverse XL by R, right? So this triangle is defined as the impedance triangle. So these are individual triangles. There are total 3 triangles for series RL circuit. And now my next job is to define as a power triangle where I am going to multiply all this vector by the term current I. So first vector is first x-axis, you can see I into R, where I multiply by I, it becomes I square into R. So from this I can be able to draw the power triangle where my first power is defined as the real power, or it is called active power. Now this power is only because of the resistance, right? So this power consumption is made by the resistance. That's why it is called a real or active power. So that I define as P is equal to VI cos phi, and the equation is I square into R, right? Same way, if I define my reactive power, which is done by the reactive part, then reactive part is the inductor, right? So I can define my reactive power Q is equal to VI sin phi. Straight away from this triangle, you can see here the x-axis is always represents the cos term, and y-axis is always represent the sin term, right? So from this, reactive part is a part of the y-axis where Q is equal to VI sin phi, that is equal to I square into XL, right? Now the combination of all this is part of the circuit. So overall circuit power I define as apparent power S is equal to V into I, and if I put V is equal to I into Z, then this apparent power S is equal to I square into Z, right? Now here understand properly what is a real power, what is an active power, what is a apparent power, what is a reactive power. So let's individually discuss. My first term is a real power. Before that, we have to find the overall circuit efficiency of this RL, and that circuit efficiency we define as a power factor, and that power factor is defined as the ratio of real power to the apparent power. Real power is the power consumption across the resistance, and the apparent power is the overall circuit power. So in another sense, it is called circuit efficiency. So if we put my real power, that is equal to I square into R, divided by apparent power, that is equal to I square into Z. So that term is defined as R by Z, and from this triangle you can see it's a cos phi. So cos phi is equal to R by Z, right? So here power factor is the most important parameter in terms of to define the circuit efficiency. So here you can see the power factor PF is equal to cos phi, and that is equal to R by Z. Now let us discuss individually what is a real power. So from this you can be able to understand that real power is nothing but it is an active power consumed by any circuit, right? So it is nothing but the product of RMS voltage and RMS current and the cosine angle between the voltage and current, that is called VI cos phi. So from this I can be able to write the active power P is equal to VI cos phi, and the unit of this power, since it is a real power, so the unit of this power is either watt or kilowatt, right? Now what is the reactive power? Again, power drawn by the circuit due to the reactive part, right? So it's a multiplication of RMS value of voltage and current with respect to sine wave. So you can see here the reactive power is nothing but I square into XL, and that is equal to VI sin phi. That unit is always in a VAR, which is called voltage ampere for reactive part, or kVAR, right? It's a kilo voltage ampere reactive part, right? Same way, the apparent power is called the overall circuit power, and this is always because of the impedance of the circuit. So I can define this apparent power, that is equal to S is equal to V into I, right? And V is equal to I into Z if I define. So then the apparent power S is equal to I square into Z. Now the unit of this apparent power is defined as VA, so voltage in ampere, right? So from this you can be able to understand all our 3 points: the relation of voltage and current, phase difference of voltage and current, then the power calculation with the help of phasor diagram and waveform, and lastly all the individual powers across resistance, inductor, and overall circuit power. Thank you very much, dear students. If you have any doubt, please write in the comments.